Hello everyone, welcome to lesson 9-3, probability of compound events. We will continue to answer our essential question, how can you predict the outcome of future events, with the new vocabulary of sample space, tree diagram, compound event. Real World Inc. Travel. Amy wants to pack enough items to create 6 different outfits. She packs 1 jacket, 3 shirts, and 2 pairs of jeans. Can Amy create 6 different outfits from her clothing items? Complete the table below. So we have, she packs 1 jacket, okay? 3 shirts, and 2 pairs of jeans. With this clothing, can she combine them in so many different ways that she can create 6 different outfits? Well, let's see. 1 outfit, 2 outfits, 3 outfits, 4 outfits, 5 outfits, and 6 outfits. So 1 outfit, clothing item, jacket, shirt, jeans. Sure. Now the shirt 1 and jean 1. A jacket again, shirt 1 and jean 2. So the only thing that changes is the jeans. Jacket, shirt number 2 and jean number 1. This is a whole different one. Just jacket and shirt 2, okay? And just a jacket and shirt 3, and just a jacket. Now here's one thing I kind of don't agree with in this example. These are not 6 combinations because you can't just only wear a jacket, right? I mean, you could physically just wear a jacket, but does not constitute as an outfit. And a jacket and a shirt does not constitute as an outfit. You need pants. You cannot go out in public without pants. So, but this is the way it would break. And this is a table. So for question 2, we're being asked, the table is an excellent example of an organized list. What is another way to show the different outfits that Amy can create? We have a tree diagram. With a tree diagram, we can show all the different combinations of outfits, and I will show you this more on the next page. Number 3, describe another situation for which you might want to list all the possible outcomes. Because everyone knows I'm a big fan of food, I think of these 2 examples, ice cream flavors or pizza toppings. You can make, let's say you have 3 different flavors, vanilla, strawberry, and chocolate. How many different combinations of 2 flavors could you make with those 3? And pizza toppings, you could have ham, bacon, cheese, pineapples. And how many different types of pizzas could you make with those toppings? So the key concept of this lesson is that the set of all the possible outcomes in a probability experiment is called the sample space. Organized lists, tables, and tree diagrams can be used to represent the sample space. The sample space will show you all the possible combinations, all the possible outcomes. Let's look at example 1. The 3 students chosen to represent Mr. Baldrick's class in a school assembly are shown. We have the students here, Adrian, Carlos, and Greg. All 3 of them need to sit in a row on the stage. Use a list to find the sample space and the possible outcomes for the different ways they can sit in a row. Okay, use A for Adrian, C for Carlos, and G for Greg. Use each letter exactly once. So we have Adrian, Carlos, and Greg. The way we have them on the table. That's one way. Then we could flip around Carlos and Greg. You see that? We flip them around. So we kept Adrian in the front. And then we have Carlos, Adrian, and Greg, and so on. So there are 3 of them. And in total, there's 1, 2, 3, 4, 5, 6. 6 different combinations in which they could sit. For example 2, we're going to see how a table diagram is used, a tree diagram, and what the sample space is supposed to look like. A car can be purchased in blue, silver, red, or purple. 4 different options. It also comes as a convertible or hardtop. Okay, so convertible, you can get it blue, silver, red, or purple, or hardtop, you can get them in blue, silver, red, or purple. Use a table or a tree diagram to find the same sample space, right here, for the different styles in which the car can be purchased. Okay, so here we have the colors: blue, both of them, blue convertible and blue hardtop, silver convertible and hardtop, red convertible and hardtop, and purple convertible and hardtop. This is how it would look on a table. We could also just write them out like this: the list of colors and convertible and hardtop for each one. Okay, and the sample space. So you could have a blue convertible, blue hardtop, BH, silver convertible, and so on. So how many would we have? 1, 2, 3, 4, 5, 6, 7, 8. Using either method, the sample space consists of 8 outcomes. The tree diagram could also look like this. Now I'd like to mention why it's called the tree diagram. You see how it branches out, like trees branch out? We could also do it like this, where we have convertible and hardtop. And we know that for convertible and hardtop, we have 4 options for each one, right? 1, 2, 3, 4, 1, 2, 3, 4, right? Where we have the colors: blue, silver, red, and purple. Same as for hardtop: blue, silver, red, and purple. And there you have it. Now you have all 8 options laid out. Okay, convertible blue, convertible silver, convertible red, convertible purple, hardtop, same options. So this is your sample space. And now we have an example that we can try ourselves. The table shows the sandwich choices for a picnic. Okay, so we have sandwich choices of meat and types of bread. For the meat, we have ham or turkey. And for the types of bread, we have rye, sourdough, or white. Okay. Find the sample space using a list, table, or tree. So we can use whichever one you like for a sandwich consisting one type of meat and one type of bread. So how many different types of sandwiches can we make with these options? If you think you know how to do it, please pause the video and try it yourself now. Okay, so we have ham, turkey, rye, sourdough, and white. Now I know that you could use a table, you can use a tree diagram to make something that looks like this. I know that for ham, I have 3 options. Rye, I could have ham with rye, I could have ham with sourdough, or I could have ham with white, right? That's 3 options that I have, 3 combinations. I could also have turkey with rye, turkey with sourdough, or turkey with white. That's another 3 options, right? And when I add them both up, I have 6 different options. I'd like to see in class which method you use. This is just a simple exercise to show you how I got 6 options, but there's different ways to display your answers. Okay, and now for our next key concept, we're going to learn about compound events. Our friend Josh here is going to read for us.
A compound event consists of 2 or more simple events. The probability of a compound event, just as with a simple event, is the fraction of outcomes in the sample space for which the compound event occurs.
Okay, thank you, Josh. That was well read. Now, what we mean by compound event means 1 or more events happening at the same time. Okay, so that's what they're saying here, 2 or more events happening at the same time. Now, the probability of a compound event is very similar to a simple event, except it's being combined with other events happening at the same time. That's what we're trying to say. Now, let's look at this example to further understand. Okay, so here we have an example of a compound event. Let's say you have 3 coins. You have a quarter, a dime, and a nickel. Okay, and you're going to toss all 3 of these coins up in the air to see whether you get heads or tails. Well, because there's 3 different coins, it's considered a compound event, right? An event for a nickel, an event for a dime, and an event for a quarter. They all can have different outcomes. But we want to see what is, in our sample space, what is the different combinations that we can get. So what is the probability of getting 3 tails? Well, let's just see. We're going to have to check. So here we have a quarter. We have dime, and we have a nickel. Okay? If I toss up the first time that I toss it up, I might get my quarter might get heads. My dime, I have the option of getting either heads or tails. For my nickel, I can get heads, or tails, right? We haven't determined these yet. The only one I've determined so far, and I'm branching from it, is my quarter. So if I throw my quarter up and I get heads, these are my other possibilities for my other coin. If I get tails, I get the same amount of possibilities for my other coins, correct? And so then all I do is just collect my data. If quarter gets head and dime gets head, nickel gets head. Head, heads, heads. I could get heads, and tails, you see? I could get heads, tails, and heads, tails, and heads, or heads, tails, tails. You see that? Heads, tails, tails, right? Now, you're probably wondering, why isn't there any tails here? Well, that's because that's only the probability with a quarter getting heads. What if the quarter gets tails? Then we have tails, heads, tails, heads, heads, you see? Tails, heads, tails, until you hit every single possibility. So now we're asking, what is the probability of getting 3 tails? Here it is. So the probability of getting 3 tails is 1 in 1, 2, 3, 4, 5, 6, 7, 8. 1 in 8. 1 opportunity out of 8 chances. So in theory, in theoretical probability, every time you throw these coins, these 3 coins up in the air, you should get, at least one time, you should get tails, tails, tails. Now remember, that is in theory. That's theoretical probability. Experimental probability could be completely different. You might never get tails, tails, tails. So the probability for getting 3 tails is 1/8. Okay, there it is. Okay, now let's try this one together. The animal shelter has both male and female Labrador retrievers in yellow, brown, and black. Okay, well, so we have males and females in yellow, brown, and black. There is an equal number of each kind. What is the probability of choosing a female yellow Labrador retriever? Choose your word. Okay, so we have to find the different combinations and then find out what is the probability of getting a female yellow lab, right? So let's, if you know how to do this, please pause and try it on your own. Otherwise, stay on. Okay, if you paused and did it on your own, now please just watch to see if you did it correctly or not. Now what I've done is I've broken up the 2 groups into female and male. And I know that for female, I have 3 options, right? I have brown, yellow, or black, and I have the same options for males, brown, yellow, or brown and black. Correct? Yellow, brown, black, yellow, brown, black. So it should look something like this. Now I need to determine my sample space. Okay, so my sample space looks like I have here female yellow. Okay. We have female brown and female black. I'll put an L in there for black. Here we have male yellow, male brown, and male black. So we're looking for female yellow right here in the top, right? Female yellow. So the probability looks like that's only 1 in 6 chances if there's equal amount of all these. So 1 in 6 chances would be our probability. And finally, the real world example, example 4. To win a carnival prize, you need to choose one of 3 doors labeled in 1 through 3. Okay, so you have to choose one of the 3 doors. You have 3 doors and you pick one. Then you need to choose a red, yellow, or blue box. So then once you go through one of those doors, you have a choice between 3 different color boxes. What is the probability that the prize is in the blue or yellow box behind door number 2? Okay, so we're looking for the prize to be only in the blue or yellow box. They don't mention the red anymore. Notice that. Okay, so we have door 1, right? Door 1 has the 3 options. Door 2 has the 3 options, and door 3 has the 3 options. I used a table for this one, right? And we're looking only for blue or yellow box. Door 2 yellow box, yellow box. Now this is 2 out of what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 out of 9, right? The table shows that there are 9 total outcomes. 2 of the outcomes are favorable. So the probability that the prize is in blue or yellow box behind door 2 is 2 over 9, or 2/9. Okay, everyone, here's our guided practice to start class. Next class, remember to take a look through it and make sure that you feel comfortable with the content. And if you have any examples or you don't know how to do it, make sure to go back to examples as labeled. If you don't know how to do 1 or 2, go back to example 1 and 2 from the video. Or if you don't know how to do this, look at examples 3 and 4. Okay, everyone, see you in class.